Hi guys, welcome back to my channel. So before we start, please don't forget to hit the subscribe button and the notification bell for more videos. Alright, so for today we're going to have special right triangles. Okay, so when we say special right triangles, these are the theorems that we can use when we're actually looking for two unknown segments of a right triangle. So unlike in a Pythagorean theorem, we are only looking for one measurement and then we have two given. In this case, we're going to look for two measurements of a right triangle or two legs of a right triangle and then using one given measurement. Okay, so that's the thing. Those are differences between Pythagorean theorem and the special right triangles theorem. Alright, so before we start, please, I would like you to prepare calculators or scientific calculators and scratch paper for you to easily follow with the discussion. Okay, so then I can assure you that once you are able to get the tricks, so it's easy for you to compute for the unknown measurements using the two theorems about special right triangles. So let's start first with Theorem 77, Isosceles right triangle theorem. So we also call it the 45 degrees, 45 degrees, 90 degrees triangle theorem. So here's the definition. In an isosceles right triangle, the length of the hypotenuse is equal to square root of 2 times the length of a leg. So what do you mean by 45, 45, 90 triangle? So it means that two of the angles measure 45 degrees and then one measures 90 degrees. So if we're going to add it, it's actually the degree measure of a triangle, which is 180 degrees. Alright, so how is this? The 45, 45, 90 triangle is based on the square with sides of 1 unit. So just like what you are seeing here, we have a square, and then one of the properties of square is that all of the sides are congruent, and if the angles are all right angles. Okay, so you have to take note of that about a square. Okay, so let's say this is the square. Then as you can see, all of the sides measure 1, and then all of the angles measures 90 degrees. So we cannot call it a square if the angles are not 90 degrees. Alright, so if we draw the diagonals, we form two 45, 45, 90 triangles. So just like what you are seeing, if you're going to draw the diagonal, it will cut the two vertices into two half. It will cut the two vertices or opposite vertices into two. So that's the time that we can actually form two 45 degrees, 45 degrees, 90 degrees triangles. So just like what you are seeing, it's now what we call the 45 degrees, 45 degrees, 90 degrees triangle. Alright, so if we're going to draw the diagonal, and as you can see, the sides or two of the legs of a right triangle are 1 and 1. So using now the Pythagorean theorem, we can find the length of the diagonal. So you have to take note that this one has no measurement yet. So for us to be able to solve it, we have to use the two legs. Okay? So you have to remember that opposite the 45 degree angle is 1, and then opposite the 45 degree angle or another 45 degree angle is also 1. So we're going to look now for the measurement of the 90 opposite to the, or the segment opposite to the 90 degree angle. Okay, so we're going to use the Pythagorean theorem based on our previous lesson. A square plus b square equals c square. Then we will substitute the values. The value of a, or the first leg, is 1. The value of the other is 1. Substitute, it will become 1 square plus 1 square equals c square. Then let us simplify. 1 square is 1 plus 1 square is 1 equals c square. And that's it. And then, alright, so 1 plus 1 is 2 equals c square. Then we will be abstracting the square root of both sides. Okay, we're going to have now square root of 2 equals c. So that's now the measurement of the hypotenuse, or the side opposite to the right angle. Okay, so the conclusion is that the ratio of the sides in a 45, 45, 90 triangle is 1, 1 square root of 2. Just like what you are seeing here, 1, 1 square root of 2. Opposite the 45 degree angle is 1, opposite the 45 degree angle is 1, and opposite the 90 degree angle is square root of 2. So this will now be our basis in computing for the unknown segments of a 45, 45, 90 degree triangle. So let's have a practice. So if this is 4, and then based on the example a while back, if this is 4, it's the same as the other one. Okay, it's the same. So that is also 4. Okay, so in the computation, if this is 1, this is also 1. So therefore, if this is 4, this is also 4. Now, how are we going to compute for the hypotenuse? Class, you don't need to use the Pythagorean Theorem. So just simply multiply to the pattern a while back, okay? Multiply the given leg by square root of 2. So therefore, if we're going to multiply 4 times square root of 2, remember that you cannot actually multiply or combine the two because they are dissimilar terms. But we can just put them together as 4 square root of 2. Unlike if it goes like this, square root of 4 times square root of 2, the answer here is square root of 8. So because they are radicals with the same indices. But in this case, they are dissimilar. This one is a whole number, this one is a radical. That's why we cannot actually multiply the whole number to the radicand. So the hypotenuse now measures 4 square root of 2. What did we do? We just simply multiplied 4 to square root of 2. Okay, that's it. See, it's easy for us to solve it. So if that leg is 9, the other leg is also 9. It's the same. Then to get the hypotenuse, okay, multiply 9 to square root of 2. The answer is 9 square root of 2 as well. Can you follow? If not, you can actually comment down below, okay, so that we can answer your questions regarding this. Okay, for my students, you can approach me directly on my messenger or on our group chats. Okay, right. Next, if that is 2, it's the same as the leg below, which is also 2. Then to get the hypotenuse, just multiply 2 times square root of 2. It will become 2 square root of 2. Next, so if that is square root of 7, it's the same as the other leg of 45, 45, 90. So therefore, that is also square root of 7. Then to get the hypotenuse, we just simply multiply square root of 7 times square root of 2. So as you can see, they are similar. They are both radicals with the same indices of 2. So 7 times 2 is square root of 14. So that is now the measurement of the hypotenuse. Alright? Next. Now let's go backward. In this time, the hypotenuse is given, and the thing is, we're going to compute for the legs. So first is 3 square root of 2. So the trick here is we just have to divide 3 square root of 2 divided by 2. A while back, to get the hypotenuse, you're going to multiply the leg by square root of 2. This time, you're going to multiply the hypotenuse by, or rather, you're going to divide the hypotenuse by square root of 2 to get the answer. So if that's the case, we're going to divide 3 square root of 2 over square root of 2. Just simply cancel this one. The answer is 3. So the legs measure, that's the thing that we've done. The legs measure 3 and 3. Okay, can you follow? Next, 6 square root of 2. Divide by square root of 2. Cancel. Alright, so the answer will be 6. Very good. So for those who can follow, it is 6. Okay, so you can actually use your calculators as aid in actually solving, or scientific calculator, so that you can actually visualize if what is really the answer. Next, 11 square root of 2. The legs are 11 and 11. Very good. So for those who can follow, you are doing a great job. Right? Next, if that is 8, divide it by square root of 2. So as you can see, the denominator is radical, so we need to rationalize this one by multiplying it to the fraction square root of 2 over square root of 2. 8 times square root of 2 is square root of 2, and then square root of 2 times square root of 2 is 2. 8 divided by 2 is 4. So therefore, the leg measures 4 square root of 2. So for your convenience, the shortcut is just, if 8 is divisible to the radicand, just simply divide. 8 divided by 2, it's 4 square root of 2, and then put the square root of 2. That's it. Alright, so the answers, or the legs, are, that's something that we've done. Okay, just like what I'm saying, the shortcut is divide 8 and 2, you will be getting 4, then attach square root of 2. That is already the answer. It's just the same. So the answers are 4 square root of 2 and 4 square root of 2. They are just the same. Next, if that is 4, divide by square root of 2. Just do the trick that I've told you. So 4 divided by 2 is 2 square root of 2. Okay. Alright. So next, 6 divided by 2, it's divisible. It's 3 square root of 2. Alright. So for those who have questions regarding 45 degrees, 45 degrees, 90 degrees triangle, please don't hesitate to ask me. Or you can comment down so that we can answer your questions. Now let's proceed to the other one, or to the other special right triangle. Let's now have the theorem 78, or the 30 degrees, 60 degrees, 90 degrees triangle theorem. So by definition, in a 30 degrees, 60 degrees, 90 degrees triangle, the length of the hypotenuse is twice the length of the shorter leg, and the length of the longer leg is square root of 3 times the length of the shorter leg. So how is this? So the measurements now of the angles of a triangle are 30, 60, 90. If you're going to add them, you're going to get 180 degrees, which is also the degree measure of a right, or of any triangle, right? So the 30, 60, 90 triangle, if a while back in 45, 45, 90 triangle we use a square, this time we're going to use equilateral triangle to interpret 30, 60, 90. Okay, so in an equilateral triangle, all of the sides are congruent, and then all of the angles are also congruent. The angles measure 60 degrees all. 60 equals 180 degrees. Alright, so the altitude, or the height, also the angle bisector and median, cuts the triangle into two congruent triangles. So that's the time that we are able to form the 30 degrees, 60 degrees, 90 degrees triangle. Alright? So of course, at the base, we're going to cut it into two as well. We're going to have one unit. So the missing leg now is the height, or the altitude. So this is the one that we're going to solve. This creates the 30, 60, 90 triangle with the hypotenuse, a short leg, and a long leg. Alright, so that's it. Long leg is the height, and then that's the hypotenuse, opposite the 90 degree angle, and the long leg is opposite the 60 degree angle, while the short leg is opposite the 30 degree angle. Remember that, okay? For long leg, it's opposite the 60 degree angle. For short leg, it's opposite the 30 degree angle, and for the hypotenuse, it's opposite the 90 degree angle. Take note of that. We saw that the hypotenuse is twice the short leg, so 1 times 2 is 2. Alright, so we can now use the Pythagorean Theorem to solve for the long leg. This one. Okay? So a squared plus b squared is equal to c squared. That's the Pythagorean Theorem. So we're going to substitute. A is unknown, that is the long leg, plus 1 square, which is the short leg, and then equals 2 square, which is the hypotenuse. Simplify, we're going to have a squared plus 1 equals 4. Then we will combine similar terms. It is now a squared equals 3. Extract the square root of both sides. It's now a equals the square root of 3. That's it. The ratio now will be 1 to square root of 3. So opposite the 30 degree angle is 1, opposite the 60 degree angle is square root of 3, and opposite the 90 degree angle is 2. So the ratio that you're going to remember now is 1 to square root of 3. A while back in the 45, 90 degree angle, it is, what is it? 1 square root of 2. That's it. Alright, so the key is to find the length of the short side. Okay, so example 4. Always remember that we are beginning at the short side. So if this is 4, to get the hypotenuse according to the pattern, remember it is 1 to square root of 3. So multiply 4 by 2, that's 8. And then for the long leg, just simply multiply 4 by square root of 3. It is now 4 square root of 3. So for those who can get it, very good. For those who cannot, okay, so let's have another examples. Right? So if that is 5, to get the hypotenuse, multiply it by 2. So it is now 10. 5 times 2 equals 10. To get the long leg, multiply it by square root of 3. It's now 5 square root of 3. Then, short leg again, 7 times 2. For the hypotenuse, it's 14. And then for the long leg, it's 7 square root of 3. Next, square root of 3 multiplied by 2, it is now 2 square root of 3. Remember, 2 is a whole number, square root of 3 is a radical. They are dissimilar. Just put them together when you multiply them. Then for the long leg, square root of 3 times square root of 3 is just simply 3. Why? Square root of 3 times square root of 3 is equal to square root of 9, and 9 is a perfect square. That's why if you're going to take the square root of 9, it is 3. Next, square root of 10 times 2 is 2 square root of 10. Square root of 10 times 3 is square root of 30. Let's go backward. So the hypotenuse is given, and then we are going to get first the short leg. To get the short leg, class, you have to divide it by 2. A while back, we multiplied by 2 to get the hypotenuse. This time, you're going to divide by 2. 22 divided by 2 is just simply 11. And to get the long leg, 11 times square root of 3 is just simply 11 square root of 3. Then 4 divided by 2 is 2. 2 times the square root of 3 for the long leg is 2 square root of 3. Then 18 divided by 2 square root of divided by 2 is 9, and then 9 times square root of 3 for the long leg is 9 square root of 3. Then 30 divided by 2 is 15 times the square root of 3 for the long leg, it is square root 15 square root of 3. This time, let's have the long leg. Okay, so let's go back again to the short leg. 23 square root of 3 divided by square root of 3. Cancel square root of 3, it's just simply 23. So solve for the hypotenuse. 23 times 2 is just simply 46. So remember that even the if the hypotenuse and the long leg are given, just solve first for the short leg. That's the first thing that you have to solve. Okay? Next, 14 square root of 3 divided by square root of 3 for the short leg, it is now 14. Then 14 times 2 for the hypotenuse, it's 28. Alright, next, 16 square root of 3 divided by square root of 3 for the short leg, it is now 16. Times 2 for the hypotenuse, it is 32. Then 9 divided by square root of 3 is just simply 3 square root of 3. Then 3 square root of 3 times 2 is 6 square root of 3. Just multiply the whole numbers. Do not include the radical. They are dissimilar terms. 12 divided by square root of 3. It's the shortcut here is, remember, if that is 12 square root of 3, if 12 is divisible by 3, just divide. 12 divided by 3 is 4, and then attach square root of 3, and that's it. The short leg now measures 4 square root of 3, and then the hypotenuse times 2, 8 square root of 3. 27 divided by 3 is 9 square root of 3, and then the hypotenuse is 18 square root of 3 multiplied by 2. Next, 21 divided by square root of 3. 21 is divisible by 3, therefore 21 divided by 3 is 7. That is square root of 3 for the short leg. That's why it is 7 square root of 3. So 7 square root of 3 times 2 is 14 square root of 3. Then 33 divided by 3 is 11 square root of 3. Then times 2 for the hypotenuse, it is now 22 square root of 3. Now, if you have some questions about 30, 60, 90, please don't hesitate to contact me, okay? Especially to my students. So let's now have the problem solving. The diagonal of a square is 20 centimeters. So how long is each side? What is the square's perimeter? So let's draw first the square. So let's say this is a perfect square, and then according to the given, there's a diagonal which measures 20 centimeters. Remember, when we discuss about 45, 45, 90, we use square. That's why this example or problem falls under 45, 45, 90. So the question for the first one, how long is each side? So we're looking for the sides of the square. To solve for it, given the hypotenuse, remember, we have to divide 20 and square root of 2. Then 20 divided by 2, divisible, 10 square root of 2 centimeters. So therefore, all of the sides measure 10 square root of 2, 10 square root of 2 cm. By the way, don't forget to put the unit. So 10 square root of 2 here, and then 10 square root of 2 centimeter also here. Next question is for letter B. What is the square's perimeter? So to solve for the perimeter of a square, just simply multiply 4 and the sides. So 4s. So 4 substitute, 10 square root of 2 centimeters. Okay, 4 times 10 is 40 square root of 2 cm. So these are now the answers to the two questions. Alright, so if you do have some questions regarding this problem, please contact me. Then, for number 2, A guy wire for a tree makes a 30-degree angle with the ground. If the distance between the stick and the base of the tree is 10 meters, here are the two questions. How tall is the tree? How long is the guy wire? So these are the two questions that we're going to do. But to better understand this one, let's draw. So let's say this is the tree, and then from the tree there is a wire on the ground. Okay, and then from the ground or from the stick, okay, so there's a distance from the tree which is 10 meters. And then according to the problem, a guy wire for a tree makes 30-degree angle. So it means we have a 30-degree angle here. So remember, opposite the 30-degree angle is the height of the tree, which is the short leg. That's the one that we're going to solve first. And then 10 meters here is the long leg. So what are we going to do? We are going to solve first for the short leg, which is the height of the tree, by dividing by square root of 3. 10 divided by square root of 3, they are not actually divisible. So the thing is, we're going to have a rationalization by multiplying it by the fraction square root of 3 over square root of 3. It's now 10 square root of 3 over 3 meters. Or using your calculators, you can actually convert this one. So let's compute it using the calculator. And then if it is a decimal, okay, just round it off to the nearest tenths. So 10 times square root of 3 equals divided by 3. So it's 5.77. So round it up to the nearest tenths, it is now 5.8 meters. That is the height of the tree. Then the next, this is 5.8 meters. Next is from the short leg, which is the height of the tree, we can now solve the hypotenuse. To solve for the hypotenuse, we're going to use the original one. Remember, the hypotenuse is twice the short leg, or the height of the tree. So therefore, it is now 2 times 10 square root of 3 over 3, which is the height of the tree. Okay? So it's now 20 square root of 3 over 3. Then let's make it decimal, which is rounded up to the nearest 10, so that we can actually visualize if how long is the wire. So 20 times the square root of 3 divided by 3. So it's now 11.55, or simply 11.5 meters. So the how long is the wire? It is 11.5 meters. Okay, so that's it. We're done with our discussion about special right triangles. For my students, don't forget to answer this one on your activity sheets. Okay, so the questions are on your books. Okay, so thank you so much for being with me today. Okay, for if you have some clarifications or comments regarding the discussion part today, you can actually comment down. For my students, if you have clarifications or questions, you can contact me. Okay, so thank you so much. Please don't forget to hit the subscribe button, Teacher Dong, okay, or the notification bell, and the notification bell rather, for more videos. Thank you so much, and have a nice day ahead.